All right, folks, we'll go ahead and get started here with the presentation. Thank you for stopping by in our workshop today. We're going to be talking about Everybot and Everybot Plus, going from the basics to blue banners. So real briefly, who are we? My name is Brian Charles Jr. I'm one of the lead coaches of Team 930. This will be my 15th season in FRC. I was a student on Team 930. I was in First LEGO League before that, so a little over 20 years in First. In my day job, I'm an embedded engineering manager at traffic and parking control, so do embedded hardware and firmware projects. Matt, you want to introduce yourself?
Hello, I am Matt Champa. I'm Team 930 CAD sublead. I'll be entering my third season on Team 930 this year.
All right, so just a quick overview. I'm going to talk a little bit about what the Everybot is, since not everybody may know what this project is all about. Go into a little bit how you can use the Everybot as a tool to raise your ceiling of competitive play. Talk a little bit about one of the success stories from this year, an example team that used the Everybot, plussed it up a little, and then had some great success, as well as what the future of First has in store related to Everybot and similar projects.
All right, so we'll give a little introduction to the Everybot. So the Everybot is a program started by Team 118 in 2014. So its main goal is to give an affordable, competitive, and elegant concept to teams early in the season. So a little history here. In 2014, it's actually a very different program. It started as a way for the Everybot team to develop a robot through the entire build season. So instead of first week, it was through the entire build season, and the documents were released as the season went through. In 2018, it was revamped to where it is now. A week into the build season, now it's all the resources. It's over 100 pages of resources that gives teams these resources earlier in the season in order to help elevate teams in the future. So one of the main aspects of the Everybot is that it's extremely affordable. It's actually less than $1,700 to build the entire base Everybot. It can also be built with essentially all basic tools found in a shop, hand tools, no CNC required to actually build the base Everybot. For example, the Thrifty Bot, which is the presentation for us, actually fabricates the Everybot side plates on the manipulator, so teams don't actually have to CNC those themselves, which is a big step up in actually giving precision machining to teams who maybe don't have those capabilities.
All right, so before we get into a deeper dive into this year's Everybot, I want to give a couple examples of past Everybots and what they were all about. So starting off here on the right-hand side, the 2018 Everybot. So those who weren't around, the competition in 2018 was taking these fabric-covered milk crates, aka cubes, and putting them up onto big giant teeter-totters, up high or down low. You could also grab these, put them in through the sidewall of the field, into what was called the vault, and get points that way. So the 2018 Everybot, as Matt mentioned, this is the first year that Everybot came out with it right at the beginning of the season, offered it as a resource to teams, had two different ways to play the game. One was accepting cubes from the human player station that you see pictured here, and this mechanism, this bucket, just pivoted over the top. And so that allowed the Everybot to be able to load in from the human player station, drive over to the switch, your switch or your opponent's switch, and just flip it over, scoring that cube into the area. Additionally, the cutout in the bottom of the robot was their ground intake. So 10 cubes started out on the field on your side, and many teams would just shuttle back and forth from this big pile of cubes over to the Alliance station wall to be able to fill the vault. So it's notable that this robot actually had two different ways to play the game, but there were separate mechanisms. That allowed the Everybot team to keep this robot very simple, very basic. You didn't have to try to make trade-offs between one and the other in order to achieve both parts of the game. And it's notable as well that they avoided the way up top scale, right? That was going to involve some kind of elevator, some kind of arm. Everybot kept it simple. This robot could still play 2/3 of the game and be very effective at it. Jumping over to 2020, Infinite Recharge. You can see that robot there. The game piece this year was the foam dodgeballs, the power cells, and the 2020 Everybot. You could score those balls into low goals or up into higher goals for more points. The low goal pictured behind the robot there is what the 2020 Everybot focused on. So they just had a roller to be able to roll the balls into this kind of hopper attached to the arm, and then be able to just reverse the roller and dump them all out very quickly into that low goal. Didn't try to do a shooter, didn't try any kind of moving the game piece, handing off from an intake to a catapult or a flywheel shooter. Just into one mechanism, reverse your rollers, and back out again to keep it very simplistic. Finally, 2022 is a very similar concept. You can see a lot of the similarities of keeping it simple and being able to play one part of the game very well. So most of you guys probably are familiar with last year's game, taking these blue and red cargo, shooting them either up into the upper hub or down low into the lower scoring of the hub. And so once again, a ground intake, just a roller to be able to roll those balls up into this little hopper on the intake, and then lift up and just reverse into the low goal. They also had some passive hangers here that allowed teams to be able to just drive the robot into the bars of the end game, be able to get hooked onto there without having any pneumatics, any motors, nothing up top had any kind of actuation. All right, so jumping into the 2023 Everybot. The goal, like Matt said, is build a minimum competitive robot. So what do you guys think, just to get a little bit of feedback here, get some interaction, what would the minimum design requirements be for a competitive robot this year? We've got the benefit of hindsight, right? We all saw, 6+ weeks of the game. We saw champs. We saw everything. So we've got a little bit of hindsight. But in autonomous, what would a robot have to do to be competitive?
Manipulate or build on charge station or manipulate game pieces.
Yeah, so being able to drive onto the charge station, right, and balance, that's, driving straight, maybe a little bit of code to balance, but you could just drive up and stop there. What else?
Be able to at least pick up the game pieces.
To pick up, are you saying the preloaded ones that are on the field?
Yeah.
Okay. So being able to preload. If you're going to pick those up, what would you probably do before that? Every robot starts with a game piece, right? So you probably score that preloaded game piece. Exactly. Okay, so we've got some moving charge station, picking up scoring game pieces. What about in teleop? What should robots be able to do in teleop to be competitive this year?
Manipulate game pieces.
Grab game pieces from where? Where could you grab game pieces from this year? Where do you think would be the minimum, like, I at least need to be able to get game pieces from here?
Human player.
Yeah, one of the human player stations. Okay, so we can at least get new game pieces, right? What about scoring those game pieces? Where do you think, at minimum, we'd want to be able to score the game pieces to be competitive? So the low, the hybrid, right? It's you just dump the game pieces out onto the floor. Okay. Anything else in teleop? Otherwise, what about our end game? What should a robot be able to do in end game to be competitive? Yeah, it should be able to balance. And fortunately, this year's game didn't require a separate mechanism. If you could drive, you could go up and balance. Excellent. All right, let's take a look at what the Everybot team came up with. And reminder, this is what they came up with 2 or 3 days into the build season. They didn't have the benefit that we did. So, autonomous, Everybot team says robot must be able to score their preloaded game piece, must be able to score mobility, so just drive straight to get out of the community, and be able to dock and engage on the charge station. Drive out, balance on the charge station. So they didn't say picking up off the ground. That was something they said, nope, that's a little bit too far out of our scope. Teleop, scoring cubes in the bottom and the middle rows. So they gave a little bit more to be able to score both spots in both cubes and cones in either of those rows. Acquiring cubes and cones from the substation, so from our human player areas, avoiding the added challenge of trying to pick up off the ground. And then they also put in here playing defense in front of the opponent's zone while having all of your robot within your frame perimeter. You can tell this is probably a little carryover from 2022 when there was a lot of defense going on and defense with intakes out of your robot and getting a lot of penalties. So keeping that as a core requirement. And lastly, endgame, dock and engage on the charge station, pretty straightforward. They also called out being narrow enough that you could balance with other robots. You're not going to drive up there and take the whole platform over. Now, it's good to keep in mind these are the minimum design requirements as we start to jump into what the 2023 Everybot actually could do. And with that, we're going to let this speak for itself a little bit. So the first thing you'll notice is that robot scored up on the high cone node. And so while the requirements were must score low and middle, they found that without adding additional complexity, they could get all the way to the top for that loading. You can see them picking up off the double substation shelf there, being able to pick up both cones and cubes, like we talked about. Scoring all of those up on the high node there. I like the ability to drive into a wall and not break your robot, which is a pretty useful thing to design into your robot. Not always the easiest, but pit crew will like you at competition if the robot's not broken every time you come back to the pit. As well as being able to be stable, right? Adding all that weight down low to the Everybot so that it's not tipping over all the time during the matches. And then being able to obviously drive up and balance on the charge station. Everybot. I don't know that was the name of it. All right. There we go. So a little bit about the Everybot resources. Matt mentioned it already, but the Everybot team doesn't just design a robot and say, hey, here's a robot. You can go do this. They have a ton of resources out on the Everybot website. We've got a snapshot here of they've got a Discord dedicated to teams that are using this. They've got a instruction manual that's like 150 pages long, which is pretty ridiculous, but it's very detailed. So if you need to know exactly how this bolt goes into this hole and if you have to trim this down, it's in this manual on how to build that robot. They've got CAD of the robot, so if you want to pull that up on your computer, maybe check it while you're assembling it, code for the robot to be able to load preloaded code in there. A lot of great resources for the Everybot by this team and for really generating this Everybot community.
So far we talked only about the Everybot program, but there are also a couple other programs that are similar in concept. So our first one we have here is the Rev Starter Bot. This is a robot. It uses an arm mounted, or a virtual 4-bar mounted on a single jointed arm. You see here it's got a pivot, and this is a virtual 4-bar system. So it actually allows it to flip back, down the back, and sit down here. You'll see it in the video later. And come up to the double substation and grab cubes and cones from here. And here this just actually squeezes the claw, or squeezes the cube like a claw. So it allows it to grab not just cubes but also cones. So I'll talk over this a little bit, but so you see that's where it flips back, right? So it's actually has a very low package compared to the Everybot. One of the main drawbacks this year Everybot was the tippy. It was a little tippy, and you can see here it can flip all the way back and actually go from the ground, which is something that Everybot can't do. So you'll see a little bit. Actually be able to grab from the ground. See, and that's that virtual 4-bar system. But as you'll see later, this can actually only fill the hybrid and mid nodes, which is something a little different than Everybot, right? This Everybot can store all three, but can't pick up from the ground. Rev Starter Bot can do low and hybrid, mid and hybrid, but can pick up from the ground, which is a pretty big advantage, as we saw later in the season, especially with the autos. So, as well as you can see one thing I want to highlight. You can see that the Everybot team versus like the Rev Ion team, there's different priorities there, right? You saw the Everybot requirements only had the mid and low nodes, so we can see that the Rev team actually decided not to go for that high nodes, but actually stay the minimal competitive and go for those lower nodes, and then choose to do ground intake.
And this was a proven concept this season. So
yeah. So one you might recognize, actually Team 112 actually used this robot as a basis for their robot. You can see there's a lot of differences. They chose to add a specific ground intake with their cube intake, as well as use like a wheeled manipulator they grabbed from the double substation, and that worked out very well for them this season.
But using this as the same basis for the virtual 4-bar, proving that it's effective.
So as well as the Rev starter bot, we have another concept. This is the West Coast product competitive concept. So this a little bit of history here actually. This actually started as a minimal competitive concept program similar to the Everybot and the RevBot, but evolved into a competitive concept, which means they're looking at a little bit more competitive robots versus something like the Rev or Everybot, right? So this uses the Great Elevator and Great Claw, which you see this and this are both COTS mechanisms that can be bought off West Coast products for pretty reasonable price, but still a little more expensive than something like the Everybot, right? As well as similar to Everybot, this can store all locations. So go to the. So you'll see immediately that this is a little more advanced, especially programming wise, than something like the Everybot. So it can actually, you also use the wheeled intake, which is something that Rev starter bot did not use, but allows it to grab cones and cubes from the ground pretty easily. And you also see that it actually uses two elevators. It actually uses a horizontal as well as a vertical elevator to move out horizontally to the nodes. A pretty interesting thing is Team 1323, which was the world champs this year, used a similar concept. They had their vertical and horizontal elevator to score their points, which kind of shows that these concepts can be used by high-level teams, not just mid or low-level teams.
And with the Rev robot, the West Coast product robot, right? These are from businesses versus the Everybot, which is just a team. They're partially there as a resource to teams, but also to highlight their products and show you how they can be used to build a competitive robot. So hence, like Matt was saying, that entire claw mechanism, the entire elevator mechanism, are things you can purchase from West Coast products. It still requires teams to figure out a little bit how you're going to put them together, customizing the design. But as Matt mentioned, this is the basis. The same. You can watch some videos of Madtown. It's got the same flippy arm that goes out to score their stuff. So proven design at a very competitive level.
Even on the website, the goal of this robot is to show off the capability of COTS mechanisms, which is something a little bit different than the Everybot or the Rev Starter Bot, which doesn't have as many of those pre-built COTS mechanisms. So as well as that, we have, you should be wondering why you should build the Everybot, right? So as I mentioned earlier, this is actually released only a week in the build season, which is extremely fast for what a competitive concept this actually is. This allows teams to spend a little bit of time prototyping, look at their own stuff, but then after a week, you can go in and you can look at Everybot, get ideas, or even build the entire thing. As well as that, like I mentioned earlier, this is a very low cost. It's a very low risk to build. You're not spending a ton of money to get into this. And as an overall general concept, this lowers the barrier to entry for all teams. Instead of just coming out with a drive base at their first competition, you might come out with an Everybot in order to actually field a robot that can manipulate game pieces, play the game, that can help inspire a lot more people than just coming out with a completely broken robot or just a drive base. So Everybot itself is kind of meant to be built in a very short amount of time. You're able to build this in a couple weeks, and then spend more time on other aspects of a robot, right? Like drive practice programming, which is parts of the teams that a lot of them get a very low amount of time to do. Some teams going with no driver practice, only a day of programming, and it causes a lot of janky robots.
Yeah, every team is limited on money, time, technical abilities. No team has an infinite amount of those. So Everybot is just another tool to be able to maximize your team and their capabilities in each of these areas.
And as well as that, sorry.
One more?
Yeah, I was gonna say it's just so Brian mentioned earlier, but there's a lot of technical resources that come with this. It isn't just bolt together and you have a robot. Not only are you building a competitive robot, but you're also learning as you do it. So hopefully a team can build Everybot 1 year and then graduate from this base, possibly adding on to it, possibly building your own custom robot to help elevate these teams. The goal is not to have a team run on Everybot every single year and only do that. The goal is to elevate the teams and help them move on to a higher competitive level.
All right. let's talk Everybot Plus. What is Everybot Plus? It's a word that I made up when I was trying to figure out what to call an Everybot that you add stuff onto. And we just want to be like Disney Plus and Apple Plus and everything Plus. That's what it is today. No, so Everybot Plus is kind of the term we came up with for taking the Everybot and that's not the finish line. That is a milestone along the way. So using that as a way, like we just talked about, right? Increase your speed, or use enhancements to that to increase the speed, mobility, your competitiveness at an event. Leveraging the design, right? You have a proven design. You have something that you know will work. You know that if you cut the metal tubing to this length and you mount it at this height, it's going to reach the scoring location. You're not going to have to spend a day or two or a week trying to figure out, saying, whoops, this one's too short, our geometry's wrong. Use all of these things that some really smart people at NASA figured out for us in order to then spend the rest of your time, how do you plus that up? So playing to your team's strengths of maybe you've got really strong CAD people in design. You've got a really great fabrication team. Your software, right? There's so much abundance of software tools out there, adding sensors and vision. So we saw the video earlier of the 2023 Everybot, right? What are some areas of that robot? Let's say your team built this, you finished by week 3 because you guys are really great at following all the long instructions. You got 3, 4, 5 weeks before your first competition. What could be enhanced about the 2023 Everybot?
Add a swerve drive.
Add a swerve drive. It wouldn't be 2023 if it wasn't talking about swerve drives. Excellent. What else?
Ground intake.
Do a ground intake, right? And you're thinking of some of these things, right? We talked about, hey, the minimum requirements. There were things that the Everbot team purposely left off. Swerve drive was one. Ground intake was one. Any other ones? You might be able to enhance the capabilities beyond just what's provided by the Everbot team. Maybe in like the first part of the match we talked about.
More pieces autonomous.
Yeah, so you could go beyond just getting mobility, right, or just driving on the charge station. Exactly. So let's talk drivetrain enhancements. Swerve, you nailed it. Swerve is everywhere today, and a lot of that is in part to all of the off-the-shelf Swerve solutions that are available. So we listed a couple of them here. West Coast Products has Swerve X that they have come out with a couple of years ago. Swerve Drive Specialties, that's what we have used in the last couple of years. Very popular. This pictured here is their Mark IV-i, inverted. They've got a couple different variants, but Swerve Drive Specialties is very popular. I know Andy Mark sells SDS modules. And then Rev also came out with their own Swerve this year, the Max Swerve. And a lot of teams have had good success with this. They had a few hiccups along the way with their wheels, but you get those bumps out of the road, and it's a solid product. So there's a lot of mechanical and electrical solutions available today for Swerve, as well as then the software to go along with it, right? Putting the Swerve together is only half the battle. If you have a great Swerve bot and no code to run on it, it's going to be a bad time. So several of these vendors offer Swerve libraries themselves. There's a lot of teams that have put their code out there. If you're running with Falcons, if you're running with Neos, doesn't matter. There's teams that have example code to follow. If you're going to do that, you probably have heard this in many other presentations before, right? Buy them early if you're able to, and spend the time to learn it. Spend the time to learn how they get assembled so that if you break apart, you know how to disassemble, reassemble it. Spend the time to learn how to program it, and spend the time to learn how to drive it. That last piece is important. Otherwise, you're going to drive a Swerve drive like a tank drive, and then you kind of lose the benefit of Swerve. And with all of these off-the-shelf Swerve modules, they're very compatible, right? All of these you can see have the same type of mounting pattern, where it's meant to mount to 2x1 aluminum tubing. So if you take Everybot, you take the entire top of it and drop it on a 2x1 rectangle, you can pop Swerve in there with very low effort. Intake enhancements. So improving the Everybot's ability to pick up and score game pieces. Like you mentioned, right? Ground intake was one of the things missing off of the Everybot. So adding a ground intake. We saw with one of the earlier Everybots of 2018, that had a ground intake, and it was a separate mechanism in order to not complicate the rest of the robot on top of it. So even being able to use a ground intake this year there's still value in picking up off the ground and being able to even just score that, still down on the ground, right? All the hybrid nodes, as well as upgrading the intake. Now, the Everybot intake is a pretty solid intake. The rollers, the wheels there, like Einstein-winning teams, Madtown used that style of intake. So Everybot has a pretty solid design. But let's say you do some testing in your shop, you find, hey, we like side roller wheels instead of the top bottom. Being able to build that and then put it on with the same type of mounting pattern as the Everybot's intake means you can pop their intake off, pop yours on, test it out. If you like it, great, keep it. If not, you can modular pop the original Everybot intake in there as well. And software enhancements. So software is exploding in the world of FRC. Being able to automate actions on your robot is going to improve all parts of your game. So using some autonomous tools like pose estimators, path planner, we've had a couple workshops on those just here at this event, and there's a lot of resources available out to teams. So being able to do more than just drive straight forward, drive straight back, right? Being able to plan out the paths you're going to go, especially if you want to get more than just scoring your preloaded game piece. You want to drive out and get a second, drive out and get a third, drive, pick one up, go onto the charge station. We saw a lot of those autonomous actions this year. Using these types of software tools will help you with that. You've also got vision tracking solutions. So this year was the first year that April tags were available on the field. It was a bit of a learning curve for all of the teams, us included. But first is moving towards April tags as their visual fiducials. And so using things like Limelight or Photon Vision, using some of these resources to be able to, whether it's automating your scoring, you drive up and you can autonomously align yourself to the scoring goal, the pickup station, or even if it's just feeding that drive or that camera feedback to your drivers for improvements. If next year's game has a big giant airship in the way and you want to be able to see behind it or see cargo on the other side of the hub, having something to show back to your drivers is very helpful. And then lastly is automation of just regular tasks you're going to be doing a lot in the match. So Everybot, you can see, right, if you just drive the motor up, it's going to bring the arm up. Then you can press a button and roll your wheels in. Then you can draw your arm back down. But if you use things like encoders, you've got sensors in your robot, you can automate a lot of those processes. Be able to automatically move the arm into its position, and then after that, spin your rollers to eject the game piece. Or do the opposite for picking up a game piece and using a sensor, time of flight sensor, a push button, detecting current in order to automate some of the pickups. So you don't have to rely as much on what the drivers are able to see in a hectic match. There's a lot of, these are just a couple. There's many, many different areas for software enhancements in this and in all of them.
So you see all of them there, but we also have an example of a team that actually utilized a lot of these modifications. So the one I'm talking about is Team 1591, the Grease Gladiators. So these were actually one of the most successful teams that used the Everybot as a basis. The first modification they used, the big one, was their swerve drive. That was the big thing that elevated them. They used MK4i swerve drives, which is the same stuff ones we use. As well as that, you saw a picture of it, but they also used their ground cube intake, which actually is able to pass off cubes from the ground through their intake to the Everybot arm, and allowing them to score in the high nodes. And as well as this ground intake allowed 1591 to actually do a 3-piece auto, which would be pretty much impossible without a ground intake like that, which is one of those software enhancements Brian was just talking about. I think we can.
Next slide.
Yeah. Oh. You see here, so we actually picked them at the Greater Pittsburgh Regional. So
they were really good before we met them. So.
Yeah.
They don't need us. We needed them.
So this team won the
right down here at the bottom, by the way, so you can see their autonomous there, the ground intake.
So a little about this team. This team actually won the Finger Lakes Regional, which is before this, as well as the Greater Pittsburgh Regional. And at Worlds, they were the first pick of Alliance 7 on Galileo. So a little bit, you'll be able to see that they just passed off, and they're going to score high. So that was one of the big elevators. They were able to do something that no other Everybot could do without a ground intake. You see, this is so they see pretty much everything else is the same as the Everybot, as original Everybot. They go from double sub and then they score. See, they actually some of their programming stuff they extend beforehand, right? They come in with their arm extended and just drop it immediately as they come in. As well as that helps with their strafing. You know, with a tank drive, you have to come in, you have to go turn around, turn, and maneuver in. With sword drive, you can just maneuver right through, strafe into to the grid and score. And with also a strafing, you can also help avoid defense, just the spin move on defense, the kick off bots trying to defend you.
And having a good robot is only half the battle, right? If you've got the world's best robot and you have no time to practice, you're going to be stumbling out there with that great robot. So by keeping the Everybot arm, the Everybot structure, right? They didn't try to bite off too much. They said we could do this, throw it on swerve, add a ground intake. This allowed their drive team weeks of practice before they showed up to their first event. Part of the reason why they seeded first and won Finger Lakes was a week 1 or week 2 regional. And at those early week regionals, just being consistent is like almost a guarantee for you to be, a winner or be very competitive. And so using the Everybot team in their design, they didn't have to design their own arm. They didn't have to design their own rollers in order to pick up the game pieces. They could work off of the Everybot resources and then just be able to enhance it, but get all of that drive practice. That's what really puts teams above and ahead. So that's why they look really good as well out on the field. It's not just the robot itself, it's the fact that they were able to use the designs, do that work very early in the season, get that drive practice that led them to win 2 regionals, and as well as, I didn't realize until today that they were part of the world high scorer in quals. So pretty cool.
And like this really did pay off for them. According to Statbotics, at least, they're ranked 40 worldwide and number 1 in New York, which is a pretty major accomplishment there. So one of the things we're looking for in the future is the 2024 Kit Up Hearts robot. So in the past, I'm sure all you know, the first releases their Kit Up Hearts drivetrain, right? That's the basic drivetrain is consistent, and teams can opt in or out to that to get their drivetrain. But this next year for 2024, they're actually making an Everybot-like program that will be included in the Kit Up Parts. So it's like actually in addition to your Kit Up Parts drivetrain. This is actually inspired by the Everybot program and is meant to help lower the barrier of entry to teams. You know, one of the biggest obstacles is actually teams being introduced to these resources. This is directly from FIRST in an official capacity, so teams will actually be able to get this right away. You'll probably see this in the game reveal video on kickoff, right? And like I said, this is a major step in lowering the bar for teams entering the space, or even older teams who maybe are struggling.
I think it's important to note, right, this is taken straight off of FIRST website from their announcement of it. It's not just here's a Lego kit, follow the instructions, and you're done. Just like Everybot, it's a lot of resources, but it's supposed to include, the team has to be manufacturing some of the parts. Not with, have to have a CNC, but they're manufacturing, they're putting it together, they're learning along the way. This just helps so that, a team with not as much resources is able to still do that. Or in our case, like we've talked about, we've opted out of the drivetrain for many years. We're talking about opting in for this and using this as a tool for our younger students, the rookies, second-year students on our team, to be able to put this together and get us a robot that plays the game in a week or 2 weeks of build season. That gets us way more drive practice. You interact with the game pieces, you do all that learning that really allows for the iteration that sets teams apart. So I'm very excited for this to come out next year.
So to recap, Everybot and similar programs are meant to be simple, competitive, and affordable designs. They come out and they're ready for teams to use. And on top of that, every team should use Everybot as a resource to help them in their season. We actually used Everybot early on in our season. There are pictures of our robot with an Everybot manipulator. So this is not just something that rookie teams or new teams should be using. It should be every single team should be looking and really considering the Everybot as a good resource to use. As well as that, like we've mentioned a lot, this is an opportunity for teams to play their strengths. You don't have to spend as much time fabricating, programming. If you already have this basis, you're able to really prioritize your needs and wants to elevate your team to the next level, really.
So if there's one thing we can leave you with, it's that Everybot's a great tool. We're not saying we want every team to show up to Wisconsin Regional next year with an Everybot, but every team should use it as a tool, consider it, try some things out. Like Matt said, we built that intake, and it just we found something else that worked better. We went with that, but it was on our shop. We should have brought it here to
Yeah,
show
I
off.
know, yeah.
It was a weird monstrosity version of it, so pretty ugly. But it's a great resource that all the teams should use, so that you're not just starting at ground zero every year. You've got that as a building point, jumping off point. All right, that's all we've got for our formal presentation. So we'll open up if you guys have any questions about any of the stuff we went over here. Or is your questions about like how much of the thrifty freebies that you're gonna get? Which is okay. Cool. Well, thank you guys for sitting in. Appreciate you sitting through this with us. Go tell people to tell people to look at Everybot and plus it up. All right. That's all we got. Thank you.
Thank you.